रियल टैग से ओके, शायद आनी चाहिए अभी तो। लेट मी चेक। ओके, आवाज़ तो आ रही है इस पे। ओके, नाउ इस पे हैव टू सेट अप सम प्रॉपर्टीज। नो, ओके, फिल्टर्स, फिल्टर्स, नॉइस गेट। हेलो, 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 हैं, हेलो, 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 दिस इज अ माइक चेक। माइक चेक। हेलो, 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 माइक चेक। हेलो, माइक चेक। हेलो, माइक चेक। हेलो, माइक चेक। हेलो, हेलो, माइक चेक। हेलो, माइक चेक। हम्म, हम्म, यार, हेलो, 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 ब्रो, अबे यार, कुछ और भी डालना पड़ेगा शायद से इसमें। वॉइस सप्रेशन। हेलो, हेलो, रिलीज टाइम वगैरह टाइम क्या क्या होते हैं यार, ये सब समझ तो नहीं आ रहा अभी। नॉइस सप्रेशन भी डाल दिया है, कंप्रेसर भी डाल दूँ क्या? रेशियो अटैक, ओके। आउटपुट गेन, रिलीज अटैक, थ्रेशोल्ड। थ्रेशोल्ड कम है तो ज़्यादा आवाज़ आ रही है, ज़्यादा कर रहा हूँ तो कम आ रही है। ज़ीरो कर दिया तो ठीक रहेगा शायद। रेशियो को ज़्यादा करना तो क्या होगा? हेलो, 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 हेलो। नो आइडिया भाई। अटैक को अटैक ज़्यादा करूँगा तो क्या हो रहा है? कुछ समझ नहीं आ रहा। गेन कम कर रहा हूँ बस। हेलो, 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 हेलो। ओके।
Java as well. And similarly, if you're someone who's using Python or JavaScript, you can also do similar kind of changes like one or two lines of changes and the code will start running in Python and JavaScript. So it doesn't matter which language you're coding in, you can definitely watch this entire playlist. So without waiting, let's get started with the first thing. What is a linked list? Now, till now, you know data structures which store elements. Now, one of the data structures you know is array. So imagine I define an array of size 4. It'll be storing something like 1, 3, 2, 5. It stores 4 integers. Why does it store 4 integers? Because the data type is defined as integer. Now, if in the future I come across and say, hey, can you please add one more element to this array? Like, can you please add 8 to this particular array? Can you add? No, you cannot add. Why? Because the array is of fixed size 4. So the size is fixed 4. You cannot add one more element. So arrays are of fixed size. Where is the array stored? So there is something as heap memory in the computer, and the array is stored in a contiguous location. What do I mean by contiguous location? And this is the index 0, this is the index 1, index 2, index 3. So the index 0 is followed by index 1, followed by index 2, followed by index 3, and they are in the contiguous location. So imagine if this 0th index is at some memory address 787895, something like this, then this one will be at 787896, right one after. This one will at be 97, this one will be at 98. So they are at the contiguous location. So that is why an array is easy to traverse index wise. So you cannot increase the size of the array. At the same time, you cannot decrease the size of the array. So this is where something like linked list comes in. It's a data structure which helps you to increase the size as well as decrease the size. So how does this data structure look like? Now array will be like over here. If I'm defining array as integer, it'll be storing integer. What if I define it as double? In that case, the array will be storing double. What if I define it as a list? In C++, the list is vector int. In Java, it is list of int. If I define it as vector or list, what will be like, what will every index store? It'll technically store a list at every index. Yes, it'll technically store a list at every index, right? So what is a linked list? Linked list is a similar data structure, but the difference index, yes, it will technically store a list at every index, right? So what is a linked list? Linked list is a similar data structure, but the difference is they're not in contiguous location. Yes, they're not in contiguous location. So imagine I ask you to store these 4 elements in a linked list. So what happens is you store 1, you store 3, you store 2, you store 5, but they are stored in the heap memory in like, it's not a contiguous location. So if I have to draw you, imagine this is the heap memory. 1 might be here, 3 might be here, maybe 2 is here, and maybe 5 is here. So there is no certainty that 1 will be here. 1 can also be somewhere on the right of 2 or somewhere like this. If the memory location of this is 985697 something, this can be anything, anything. So they are not in contiguous memory location. So that is the first thing about not in, about linked list, that the not in contiguous location. They can be anywhere. So if they can be anywhere, you definitely cannot go like index 0, index 1, index 2, index 3. And how do you store these elements? Remember one thing, in linked list also you can store integer, double, list, strings, characters, whatever data structure you want to store, similar to array. The only difference is they're not in contiguous location and their size can be increased at any moment. Their size can be increased at any moment. Why? Because array was in contiguous like memory location. So you're not sure if the next, like wherever this was, if the next location is free or not. But when it comes to linked list, there is no next location. It can just, if you add one more 6, just find a place in the heap memory and store it. This is the advantage of linked list over arrays. You can increase the size, you can decrease the size. Now the question comes up, how do we store it? So what happens is, over here, or not, and their size. One thing where about linked list, that the not in contiguous location. They can be anywhere. So if they can be anywhere, you definitely cannot go like index 0, index 1, index 2, index 3. And how do you store these elements? Remember one thing, in linked list also you can store integer, double, list, strings, characters, whatever data structure you want to store, similar to array. The only difference is they're not in contiguous location and their size can be increased at any moment. Their size can be increased at any moment. Why? Because array was in contiguous like memory location. So you're not sure if the next, like wherever this was, if the next location is free or not. But when it comes to linked list, there's no next location. It can just, if you add one more 6, just find a place in the heap memory and store it. This is the advantage of linked list over arrays. You can increase the size, you can decrease the size. Now the question comes up, how do we store it? So what happens is, over here in an array, it was index 0, index 1, index 2, index 3. And we could easily traverse, right? But how do we traverse? In linked list, we do something different. We are storing element, that's basically the data. At the same time, we store something as next. At the same time, we store something as next with every data. Now, what is next? You need to know. If this is at 0th index, how do you know this is at the first index? Because it is exactly the next memory location. So in linked list, if you know the starting point, if you know this is the starting point, how do you know the next? Only if you can somehow remember where is the next guy in the entire heap memory. If someone can tell you where is this tree in the heap memory, and it's easy to locate it. So this is how you'll traverse. How will you traverse? Very simple. So for example, let's call it as memory location 1, memory location 2, memory location 3, memory location 4. So basically the first element is at memory location M1. M1 can be anything in the heap memory. Second one is at M2. This one is at M3. This one is at M4. So what we do is we remember. We remember the starting point. Usually the starting point of the linked list is called head of the linked list. Remember this. Usually the starting point of the linked list is called head of the linked list. And the head of the linked list is stored at the M1 location. Remember this. Head of the linked list is stored at the M1 location. Where is the next? The next is stored at M2. So this starting element is storing the next. So what you do is you basically say next is at M2. So whenever you are starting from head, because you know the head is at M1. So in order to go to the next one, you go to this element and you say, where is the next? He says at M2. So you straight away go to M2, straight away go to that memory location and access that element. So what you're doing is you're invisibly creating a link, or you you're in. So what you're doing is you're invincibly you're invisibly creating a link. How are you creating a link? You're saying, hey, your next element is this one. Then over here, you're storing your next is at M3. So again, kind of creating a link. Over here, you're saying the next is at M4. So you're creating a link, correct? Where will this point to? Does it have any new element? I repeat, does it have any new element? No, so there is nothing beyond M4. If there is nothing beyond M4, what you will do is you'll straight away see null. In Java, it is null. In C++, it will be null pointer. Null pointer. That's it. So what you did was you stored M2, which is basically this link will not be created in the heap memory. Just to explain that from 1 is the link created. Then there's the link created. And how is the link stored? You just remember where is my next. If you remember it is at M2, you can straight away jump to M2. And then you know the next is at M3, you can straight away jump to M3. Then you know the next is at M4, you can straight away jump. Then you know the next is null, which means this is the tail of the linked list. What is it called? The tail of the linked list. Tail. Remember this word. It's called tail of the linked list. Okay, so we have understood what is a linked list. I'll not go into the implementation details as of now. I just wanted to give you a context how to store it. So just imagine someone tells you increase the size. I want to add 8. How do you add 8? You basically say put that into the heap memory at some random location M5. Put that into the heap memory at some random location M5. Once you have done this, I knew that the tail of the linked list was at this portion, which is at M4. I knew that the tail was at M4. If I know the tail was at M4, what I'll do is very simple. I'll just go and I'll say, hey, your next is now at M5, which is basically you hypothetically create one more. So just erase it. You create one more, and that one more will store 8. And this next, my bad, use blue color. Yeah, the next will be what will be the next for this null? Yes, or null pointer for C++. That's it. It is easy to add because you don't have to be dependent on the next memory location. Wherever you find a place, just store it. Again, this M5 can be anything. This is how you can increase the size. I know you can think how to decrease as well. It's very simple to decrease as well. Just remove it. Yes. So, anyways, I'll not go to these things. So we'll talk about that when we do these things. We'll be talking about that. No way. Okay, what's the next? So I've got the concept of linked list. But the next question that might be in your head is, hey, where is it used? So if I talk about data structures, it is used in stack queue. This is the most common data structure that can come to your head. Why? Because what is linked list? No fixed size. And if you know stack has no fixed size. You put on elements, it keeps on increasing. You take out elements, it keeps on decreasing. So stack and queue are primary examples where the linked list data structure is used. You cannot use an array data structure because they're flexible in size. That is where it is used. Where in real life? In real life, we always use it in a browser. Yes, we always use it in a browser. So this linked list that we did talk about was a 1D linked list. What do we mean by 1D? We're just keeping a forward pointer. I'm just remembering what is the next. I'm not remembering what is the previous. So it is in 1D. like it's in one direction. Got it? So basically remember the next, so it's a direction in one. I can go from 1 to 3, but I don't know. At 3, I don't know what is my previous one. From 3, I can go to this 2, but I don't know what is my previous one. So it's a 1D linked list. Since I'm talking about real life example, one of the classical real life examples is a browser. Yeah, let's talk about a browser. What happens in a browser? You open a tab, and let's say you search something. First tab, you like, this is the first page you landed. You search something, it gives you some results. Imagine you search take you forward, it gives you takeyouforward.org. You go to there. From there, you go to that A to Z course. From there, you go to our article, and you do everything in one tab. What are you doing? Initially, it started with search. After that, you went one place ahead. After that, you went one place. After that, you went one place ahead. But on the tab, if you click the back button, it actually takes you back. It again takes you back. It again takes you back. And if you again click the forward button, it takes you front, takes you front. And if you go beyond that something, it again takes you, right? Looks like a linked list. You don't know the size initially. How many things will you be searching? How many things will you be going deep into? And you can always come back as much as you want. You can always go as much as you want. So perfect example where linked list is used. Got it? So the next question, what is the data structure that we will be using? In order to understand the data structure, we'll have to know about struct and class in C++ as well as in Java. So I'll be telling you about the concept of self-defined objects. So please hear it out properly. It doesn't matter if it is C++ or Java, because both of them are identical. So just hear me out in C++. Right after C++, I'll be telling you in Java. Don't skip to Java. Hear the C++ part because it's super easy. So before going into the struct and class concept, I'll write a couple of lines. Int x equal to 2, int star y equal to and of x. What are these couple of lines doing? And if I write cout of y, so basically cout means print of y, what happens? So I'll tell you what happens. This line creates x. This line basically creates x in the heap memory somewhere. In the heap memory somewhere. Stores the value 2. This line, when I say and of x, gives me this memory location. Imagine the memory location is M1. This X is located in the heap memory at some memory location M1. So it will give me M1. That M1 can be anything. It can be any random number. And this is being stored here. So you cannot store a memory location. You cannot store a memory location. So in C++, what you do is you store a pointer to it. You store a pointer to it. So what I know is I have a pointer to this memory location. I have a pointer to this memory location. So if you try to print cout, like if you try to print y, you'll get the pointer to this memory location. Got it? So this is very important. And how do you, this is the pointer stuff. Yes, this is the pointer stuff. Int pointer. So this is how you store it, because this variable was 2. Sorry, this thing was an integer. That's why in order to store a pointer to its memory location, you have to give int star. That's how it works in C++. In Java, you just have to store the instance, and it's very simple. I'll be coming to that afterwards. What are we storing? If you're defining an array, you're just storing int array of size 10, and it always stores ints, right? Integers. In linked list, what are we storing? Let's scroll up. We're storing data for sure. At the same time, you're storing the pointer. Please carefully observe. You're storing the pointer to the next, which is basically M2 here. You're storing the pointer to the next. So we're storing two things. One is the data itself. The next thing is the pointer to the next. So I know one thing. My box as of now is storing the data and the pointer to the next. So this is together. If you remember the example, this just has an integer. That's why I could get a pointer to its memory location by saying int star. But if I have two things inside that box, which is the data and the next pointer, data and the pointer itself, which data type is this? There is no data type. This is where you have to define a self-defined data type. This is where you have to define a self-defined data type. So what you do is, you go ahead and say struct node star, sorry, not star. Open this up, and then you say int not x data. After that, you're storing a pointer. What is the self-defined data type? Node. The self-defined data type that you're creating, that's called as node. So you are storing a pointer to the next. So node star, because to the next, which is basically the memory location next. That's what you store. In order to got that? Now the question arises, how can I, just a second. The question arises, how can I initialize a value? Imagine I've been asked to add a value 2. How can I initialize that? There are multiple ways to do it. One of the ways is definitely you can say node x, similar to how you do it in a integer declaration, int x. Node x equal to, you just call the constructor node and you give the value 2 and you give null pointer, very important, null pointer. So it's basically null ptr. That's what you give. So if you give this, what happens is, this is nothing but a 2 and this is null pointer the next. So you created a variable of your type node, If you want the pointer to this, you can say node of star y, and this, quite simple. This is how you can do it. But if you just define this is just that variable. This is not the memory location. Remember, this is just an object, not the pointer to this one. In order to get the pointer, you have to do node star y. Got it? The easiest way, don't go via this. The easiest way is say node star, whatever is your variable name. If your variable name is, let's say y in this case, y equal to, just give this new variable, just give this new keyword and then write new node to null pointer. So what happens is, whenever you define something like this, it automatically stores a pointer to the memory location. So this is how you can do it. Got it? So I jumped into the code editor straight away and I've written the same thing. The only difference is I have defined these things to be public and the constructor to be public as well. After this, what I do is I say node star y equal to new node, let's say I take the array 0 value, comma, null pointer. So I've taken this and now I go ahead and say cout of y. See what will happen. I'll just run this. See this memory location being like a pointer to this memory location being printed. Got it? So you understood the new keyword, right? It directly gives you the memory, like a pointer to the memory location, and then you can store it. But what if I define it like, I don't use the new keyword and I define it like this? So what technically over here you're doing is just creating an object where these two things are there. Array of 0, which is technically 2, and null pointer. These two things are there. So if you now try to print cout, it throws you an error because it's an object. You can either take data from it and then print it. So if take data, it will print 2, or you can take the next and you can print it. So if I print the next, it's basically the null pointer. That's how you do it, correct? In case I would have defined it as this and a new keyword. In that case, I cannot print this. Why data will be giving me an error? I have to do something else, and it will be printing me the 2 value. Got this thing? So technically use this throughout the course, how easy it is. When given this array of size 4, very simple. Main thing, how do we convert an array in this? So this is also done. Now we come up to the main thing. How do we convert an array to a linked list in C++ or in Java? It's a very simple. It's a very simple. I'll just be talking about the logic here, and then I'll be writing the C++ code. I'll be copy pasting and making the changes I told, and I'll be running in Java as well. So let's assume we're given this array which has 2, 1, 3 and 8. We're given this array of size 4. What do we need? I always told you that we need to remember where is our head. We will have this node self-defined data type where we can store all the data. Initially we define the head. So what we do is we go to the heap memory and use the new keyword and create this data type where we store the 2, which is array of 0, and at the same time we say the next pointer. So what I'll do is I'll always point the next pointer like this. It's pointing to null. Null is basically x as of now. So this is something which you'll create for the first variable. I'll do it for the first variable. Done it for the first variable. So where is my head pointing? Head is always pointing to this. Remember this. Head is always pointing to this. So what I can say is, I'll erase this. My head will always be this. Always. You will never ever forget head, because if you forget head, you don't know where's your starting point. So you have to keep a track of it. Keep a track of it. And now what I'll do is, I'll take a variable mover. You'll understand why am I doing it. It's very simple. I'll take a variable mover. I'll go to the next index, which is index 1. And I'll start iterating for index 1, index 2 and index 3. Basically, apart from the first element, because first element will always be head, I start iterating through every other element. That is what I'll do. So I iterate through this element. So I need to store it in my data type. So I'll again create node equal to new node and put this. So what I'll do is I'll put this into some data type where the next is always null. Where is my mover as of now? Where is my mover as of now? Over here. And imagine this is my temporary, which is created. The temporary I've created. I've gone here. I've created a temporary by calling new node of one null. So this is created and this is now pointing to null. In order to create the linked list, what should happen? This previous element, instead of pointing to null, it should remember that its next is this. It should remember the pointer to this memory location, correct? This is basically mover. So can I say mover, your next will be temporary? Because if you remember, how will we create temporary? Node star, temporary, new, node, and the variable 1. That's how we'll create. The temporary is already a pointer to this. So this temporary can be assigned to this. Can be. So if I write this, what will happen? Instead of pointing here, this will start pointing here. Perfect. Once you have done this, don't move ahead, don't move ahead. Move this mover to this portion. And your temporary can be like, just forget about temporary. Next. This is done, you move to this tree. Let's do the same thing again. I'll create 3 and this will point to null. I'll create 3 and this will point to null. Correct? And this will be my temporary. But this is connected to this. This has to be connected to this. What will I write? The movers next will be temporary, isn't it? So what will happen? This will no more be pointing to this and it will be pointing to this. Quite simple. And once I've done this, I'll take the mover and I'll move it and afterwards I move ahead to this, which is 8. So let's again create 8 in a temporary. So temporary will now go to the next created. again what thing will happen? The mover instead of pointing to null will start pointing here, and this is definitely pointing to null. Done. After this, the iteration is over. What we have done is we have created a link to all the nodes I created. I created all the nodes while traversing, and I then attached them. So at the end, the mover will be moved here and will stop here. Can I say, since I stored the head, I know my starting pointer to the memory location. I know the pointer to this. I know that this is there because head is storing a pointer to this first node. I know where it is. So one thing that you need to remember in the questions related to arrays, they're always asking to return array or something like that. In questions related to linked list, you cannot return the entire linked list. So what they will ask you is to return the starting point. Then they will be traversing it on the backend. But they will ask you to return the starting point. Got this? So let's quickly get back into the code editor and write the code. I'll be writing the C++ code. In case you're someone who is doing it in Java, Python, JavaScript, doesn't matter. Understand the C++ code because in the Java code, there's a slight change. In the Python code, there's a slight change, and I'll be showing you that. Don't worry about that. So what's this code? After that, I'll be writing the Java code. Do not worry. And in the links, you'll be finding the Python and JavaScript code as well. So what do we need to do? We need to convert an array to a linked list. That's what we need to do. So we'll be taking a function which will be taking this array. What do we need to return? I told you we cannot return the entire linked list. So we technically return the head. What is head? We need a pointer to the head. That is what we will be returning, right? So can I say the head will always be the first element, which is array of 0. Since I have a multi-constructor, I don't need to pass the null pointer. It will always be doing that for me. What is the next step? I need a mover, which initially points to head. So the mover is standing at the first place. Perfect. Done. What's the next thing? Let's iterate. We skip the first element, which is the 0th index, and we go till the last. So let's go. What after this? We'll be creating we'll be storing this value stored in temporary. What is the next job? I need mover. Next, because I need to create the link. Next, to point to this temporary. And after that, I need to move because mover, if I go back over here, this temp was created. I had